Maximizing the area of the garden. A rectangular garden is to be constructed using a rock wall as one side of the garden and wire fencing for the other three sides. Given 200 feet of wire fencing, determine the dimensions that will create a garden of maximum area. We want to quantify to be optimized 8.
Hello, my name is Abril Garcia, and I'm going to explain the step 2 of the optimization problem from the PIA. As you can see in the image, we have a garden that we're going to use 200 feet of wire to protect it, only on 3 sides. Why? Because on the 4 sides, as you can see, is covered by rocks, which is why we won't put wire in that area. Now, our garden has a form of a square, which means that the area of a square is x times y. And the perimeter is adding all the sides of the square. As I already said, one of the sides has rocks in it, which means that we're going to use it just in 3 sides. So the perimeter will be 2x plus y equals 200 feet of wire. This will help us to determine the maximum area of the garden.
Hi, I'm Grecia Muñoz, and I will explain the step number 3 for our optimization problem. So now we want to create a function that allows to perform the task. And here we have our information about the problem, that is the area and perimeter. So we have this function that is perimeter, and we want to simplify it. So it's y equals 200 minus 2x, and then we have that the area is equals to y times x, and that means that the area is equals to 200 minus 2x times x, because this is the value of y that we have in this formula, and we have the value of x here. Okay, so now we simplify this, that is area equals to 100x minus 2x squared. And now we have the formula of the area of this problem, but in this case we want to have the comparison with the function that area equals to the f of x, and that means that f of x equals 200x minus 2x squared. And that means that for the following steps we want we follow or we are basing our procedure with this function that we did with all this information. And that's all.
So now step 4 is finding the critical point and if it's increasing and decreasing. So first we have to have a function, and how do you get this function? You have to make all the steps that we did before. So now that you have your function, you have to make it equal to 0 to find its derivative. And finding the derivative will get you the critical point. And in this case, we got that it's 50. So then you have to make a table. And in this table, you will have to write like different points or interceptions that will help you to make the derivative test. And in the derivative test, you have to choose a point between the two coordinates that you have, and that it's not too difficult to evaluate in your function. And in this case, we choose the number 10. And when we evaluated, we got that it's 160. And in this case, it's positive. And in this case, we evaluated the number 51, and we got -4. So it's negative. And these signs of the numbers will tell you that if it's increasing and decreasing at those coordinates.
To find the local maximum point, we have to evaluate the results that the previous procedures have shown. So with this information we can conclude that the x-axis of the local maximum is 50. So now we have to locate the g point. We substitute the number 50 in the function, and then after doing all the procedure like we see here, we obtain 100. So now that we have this procedure ready, we just graphic or local maximum point like we show here. There is 100 and a 15, and they both connect in the sketch.
For last, as a conclusion, we can assume that the area is as max as possible, giving us 4 as a result of x and y equal to 50 and 100. And this will be the conclusion of the problem that we explained. Thank you.